Many seniors each year engage in a quarter-long capstone project. And our next speaker, Jess Woolfolk, is a senior student in environmental studies and also biology. She is also a student worker at the Center for Environmental Justice and Sustainability. And Jess will present the research that she has been conducting for her capstone this year on mycoremediation, focusing on the potential of fungi to address soil pollution.
When I think about caring for our common home, I don't just think about the earth that we share with other humans. I think about all forms of life, from the most microscopic of plants to the largest animals. As humans, we have a responsibility to act as stewards of sustainability, but we are not in this alone. Every living organism plays a part in helping our planet thrive. By recognizing the power of nature, we can turn to ecosystem services and natural processes as allies in our sustainability efforts. Last quarter, my capstone research led me to explore one of these natural allies, fungi. Specifically, I looked at how expanding industries like agriculture, transportation, and manufacturing are contributing to rising pollution levels in critical ecosystems, especially in our soil. In response, my research focused on one central question: how can fungi be leveraged to address soil pollution, and how does their effectiveness compare to conventional remediation methods? The problem is simple. Increasing soil pollution driven by industrial expansion and urbanization poses significant ecological and human health risks, necessitating the need for sustainable, scalable, and cost-effective remediation solutions. While the current conventional techniques are widely used, they are often costly, energy-intensive, and can further degrade the soil's chemical and physical properties. This is where natural solutions come in and can offer a promising, environmentally friendly alternative. Mycoremediation leverages the natural abilities of fungi to absorb, degrade, and detoxify pollutants while simultaneously promoting plant growth and soil health recovery. This method offers a more sustainable, cost-effective, and energy-efficient alternative to conventional techniques, aligning our efforts with the restorative power of nature. So what is mycoremediation and how does it actually work? At its core, mycoremediation is a scientific term for using fungi to filter out pollutants from the environment. This process happens through both the visible mushroom bodies and the underground network of mycelium. There are two main ways this works. First, some fungi can secrete enzymes into the soil that break down harmful chemicals like petroleum products from transportation or toxic pesticides from agriculture. This process detoxifies the pollutants and transforms them into less harmful byproducts. Second, other fungi have the remarkable ability to bioaccumulate heavy metals such as cadmium, arsenic, lead, chromium, absorbing these metals into their tissues and fruiting bodies and effectively removing them from the soil. Together, these processes show how fungi don't just survive in polluted environments, they can actually transform them, metabolizing toxins and supporting the recovery of the ecosystem. And of course, because fungi are a natural solution, they don't just remove pollution, they work to help the entire ecosystem bounce back. As fungi clean up contaminants, they also improve soil structure and chemistry, making the environment more hospitable for plants. Many fungi even produce beneficial compounds called metabolites that promote plant growth, leading to stronger, healthier vegetation and revitalized landscapes. Additionally, by attracting mushroom-loving insects to feed and lay their larvae, fungi can initiate a chain reaction, drawing in birds and other seed-dispersing animals, promoting the development of a new biodiverse ecosystem in an area that was once polluted. Fungi's ability to restore ecosystems and promote plant growth make it a promising tool for use in areas like agriculture, where it can tackle pollution from runoff at the source and improve crop health and yields. It's also highly cost-effective. Spent mushroom substrate, which is a byproduct of organic mushroom farming, can be repurposed for mycoremediation, reducing agricultural waste and opening doors for sustainable partnerships. And because it harnesses fungi's natural abilities, it's incredibly energy efficient. So why aren't we using it more? Despite its potential, mycoremediation is still critically under-researched. Of the 8 empirical studies I reviewed, only one was a field-based study conducted in the United States. The rest were lab-based and from other countries around the world. To scale up mycoremediation, we absolutely need more field-based research to investigate how environmental factors like pH, nutrient levels, and temperature can be optimized to enhance fungal remediation efficiency in the field. We also need to develop safe protocols for harvesting and disposing of fungal fruiting bodies after bioaccumulation. This kind of research is essential if we want to create practical, nature-based solutions to combat soil pollution. So, this Earth Day, let's expand our idea of care. Let's celebrate not just the beauty of nature, but its wisdom. And let's invest in solutions that honor the ecosystems we rely on and recognize that nature isn't just a victim of pollution, but a partner in healing. Thank you.